Imagine standing outside on a sunny day and looking up to see fluffy, white formations drifting across the sky. These are clouds, and they're not just beautiful decorations above us, they play a crucial role in the Earth's weather and water cycle. But what exactly is a cloud, and how does it form? A cloud is a collection of tiny water droplets or ice crystals that are suspended in the air. These droplets or crystals are so small that they can float, much like dust particles. Clouds form when the air becomes saturated with water vapor, and the vapor cools and condenses into tiny droplets. But let's dive deeper into this process to understand how it all happens. The air around us always contains water vapor, which is water in its gaseous state. Even if we can't see it, water vapor is present, especially in humid climates. When the air rises, it cools down. This cooling is important because cooler air can't hold as much water vapor as warm air. As the air cools, the water vapor condenses, meaning it changes from a gas to a liquid. This is similar to how dew forms on grass in the morning or how condensation appears on a cold glass on a hot day. As these tiny droplets of water form, they start to gather around small particles in the air, such as dust, salt, or pollen. These particles are known as condensation nuclei, and they provide a surface for the water vapor to cling to. When millions of these droplets cluster together, they form a cloud. Clouds come in various shapes and sizes, each type indicating different weather patterns. Let's explore some of the main types of clouds you might see. These are the fluffy, white clouds that look like cotton balls. They're usually a sign of fair weather, but when they grow larger and darker, they can develop into cumulonimbus clouds, which bring thunderstorms. These clouds are often shown in the sky. They are formed in horizontal layers, covering the sky like a blanket. They often bring overcast skies and can lead to light rain or drizzle. When they touch the ground, they are called fog. Cirrus clouds are high-altitude clouds that appear thin and wispy, often resembling feathers. Made mostly of ice crystals, cirrus clouds usually indicate that a change in the weather is coming, such as a shift from fair to stormy weather. The term nimbus is used to describe clouds that bring precipitation. Cumulonimbus clouds, for example, are large, towering clouds that can produce thunderstorms, heavy rain, hail, and even tornadoes. Nimbostratus clouds are thick, dark clouds that cover the sky and bring continuous, steady rain or snow. These two kinds of clouds are mid-level clouds that found between 6,500 and 20,000 feet to 1,000 to 6,000 meters above the ground. Altocumulus clouds are white or gray and often appear as a sheet or patchy cloud layer. Altostratus clouds are gray or blue-gray and usually cover the entire sky, often BR. Now that we understand what clouds are and the different types, let's explore how they can turn into rainmakers. The process of rain formation is fascinating and involves several key steps. As we've discussed, clouds form when water vapor condenses into tiny droplets. For rain to occur, these droplets must grow larger. This growth happens through a process called coalescence, where droplets collide and merge with each other. Think of it as small droplets bumping into each other and sticking together to form bigger drops. For droplets to fall as rain, they need to be heavy enough to overcome the air resistance that keeps them suspended in the cloud. This usually happens when droplets reach a size of about 0.1 millimeters in diameter. At this point, they are large enough to fall to the ground, and we perceive this as rain. Once the droplets are large enough, gravity pulls them down, and they fall to the ground as precipitation. Depending on the temperature, this precipitation can take the form of rain, snow, sleet, or hail. For example, if the temperature is above freezing, the precipitation will fall as rain. If it's below freezing, it might fall as snow or sleet. In colder regions or at higher altitudes, ice crystals can play a significant role in precipitation. These crystals can form when the temperature in the cloud drops below freezing. Water vapor deposits onto these ice crystals, causing them to grow. When these crystals become heavy enough, they fall. If the air below is warm enough, they melt into rain. If it's cold, they fall as snow. This process is known as the Bergeron-Findeisen process. These are several factors can influence the amount and type of precipitation a cloud can produce. Warm air can hold more water vapor, leading to more significant amounts of rain. Conversely, colder air holds less moisture, resulting in less precipitation. High humidity levels mean more water vapor is available to form clouds and rain. Wind can influence cloud formation and precipitation. For example, wind can push moist air over mountains, causing it to rise and cool, a process known as orographic lift. This can lead to increased precipitation on the windward side of the mountains. Some regions are naturally wetter or drier due to their geographical location. For example, tropical areas near the equator receive more rainfall due to warm temperatures and high humidity. In contrast, deserts, which are often located in high-pressure zones, receive very little rainfall. The seasons can also affect precipitation. For instance, monsoon seasons bring heavy rains to certain regions, while winter can bring snow instead of rain. Do you know some facts about clouds? The first fact about clouds and rain is raindrop-shaped. Contrary to popular belief, raindrops are not tear-shaped. They start as round droplets and flatten out as they fall due to air resistance, taking on a shape more like a hamburger bun. Cloud weight. Clouds may look light and fluffy, but they are surprisingly heavy. A typical cumulus cloud can weigh as much as 1.1 million pounds or 500,000 kilograms. However, because the water droplets are spread out over a large area, the cloud stays afloat in the air. If we think about cloud color, clouds appear white because they reflect all colors of sunlight. However, clouds can look gray or dark when they become thick enough to block sunlight, which often happens before a storm. Global rainfall. The Earth receives an average of about 990 millimeters 39 inches of rain each year, but this varies widely by region. Some areas, like the Amazon rainforest, receive much more, while others, like the Sahara Desert, receive very little. The water cycle. Rain is a crucial part of the water cycle, a continuous process where water evaporates from the Earth's surface, forms clouds, and falls back as precipitation. This cycle is essential for distributing fresh water across the planet, supporting plant and animal life. The sound of rain. The soothing sound of rain can be attributed to the collective impact of raindrops hitting various surfaces. This sound is often used in relaxation and sleep aids, as it can have a calming effect on the mind. Sometimes, rain can contain pollutants like sulfur dioxide and nitrogen oxides, which come from industrial processes and vehicles. When these chemicals mix with water vapor, they form acids, resulting in acid rain. Acid rain can harm plants, aquatic animals, and infrastructure. And the last one is rainbows. Rainbows are another fascinating phenomenon related to rain. They occur when sunlight is refracted, or bent, through raindrops, splitting the light into its constituent colors. This creates a beautiful arc of colors in the sky, often seen after a rain shower. Clouds and rain are everyday phenomena that have a profound impact on our environment and daily lives. Understanding how clouds form and how they produce rain helps us appreciate the complexity and beauty of the natural world. Whether it's the sight of a clear blue sky dotted with fluffy cumulus clouds or the calming sound of raindrops on a roof, these elements remind us of the Earth's ever-changing and interconnected systems.